Airbags have this solid called sodium azide, which react with heat to form the nitrogen gas. This is the equation of the reaction, and we're trying to figure out what the work is that's done by the system here as the airbag expands. If we only have 10.5 grams of this solid, well, we should be able to use this equation, PV equals nRT, and we should know that we can use this to figure out the work, because work is supposed to be L times ATM, which turns into the joules, which is basically the liters of the volume times the pressure here. But you could use either side of this equation, so we can actually use the nRT side. Now here we're kind of looking at this delta N. This is the change of the amount of moles of gas. So the moles of gas starts from the reactant side and goes towards the product side. And how many moles of gas were changed here? Well, here we have a solid, so there's 0 moles of gas on this side, 0 gas. And then on this side, we have this stuff, which is, it's going to give us a certain amount of moles of gas. We don't really know because we have a 3:2 ratio here, but let's try to figure out how much moles of the solid we have at first. So we're going to go 10.5 grams of the solid, and then we're going to convert that to moles. So we'll just use the molar mass, 65.011 grams. That's going to be 1 mole of the NaN3. Now we can go ahead and use the conversion factor that we have here. So 2 NaN3s gives you 3 of the N2s. Well, we know that we actually have moles on this side, so we'll go and mark that as the moles of N2 that we have here. So we know we kind of have to cancel that one out. But let's go and find R that's appropriate for this. That would be 8.206 e to the negative 2. And then we have liters, ATMs, and then we have the K and the mole. So the moles will cancel out. Now we're trying to figure out the temperature. This one is in Celsius, but we're supposed to convert that to Kelvin. So 22 plus 170, 273.15. And that's going to give us Kelvin here. Now, we're not really done yet because we have L times ATM, and LATM is not joules. We have to convert that to joules by going 101.325 joules per LATM. So these things will cancel, and we'll be left with the joules. So it's a pretty long dimensional analysis here that we're doing, but let's go and plug this whole thing into the equation. 101.325. And then we can have this thing here, so 10.5. We can divide the 65.011 on top there. And we have the 3/2. And so now we have the moles here. And now we have the R, so 8.206. Is negative 2, and then we can finally get this little thing, 22 plus 2, 73.15. And yes, there we go. We finally have the joules for this reaction. It'll be 594.5 joules. And because this was an expansion, this is going to be negative work. So that's pretty cool. Bam.